Alright, so on this video we're going to review how to check to see if an equation is balanced or not. And what you should have watched prior to watching this is subscripts and coefficients. You should have this page. I'm going to review the very last problem with you, this one, and I've written it out on a separate sheet so we can really look at it. First of all, we're going to start by labeling our equation. So reactants, yield, or make products. Okay, on this equation you're going to notice something funny in parentheses behind the formula. AQ just means aqueous, means water-based. So whatever this is, it's water-based. Then you're going to notice another one used here, which is the L, and the L just means liquid. You could also see an S for solid. You could also see a G for gas. So don't let that throw you off. It has nothing to do with counting elements and atoms of each element. It's just another way that the chemist signifies what type of matter he's looking at. Alright, so we're going to go ahead and make our T-chart. Then we're going to list all atoms, all elements on either side of the equation. So we have Al for aluminum, Cl for chlorine, Na for sodium, O, and H. We want to list them the same way on both sides, just so that we can do a quick and easy check if it's balanced or not balanced. Alright, so now we're just going to count the atoms of each element on either side. So we have Al, we only have one. There's no coefficient, no subscript, so that's 1. Cl, though, goes with the subscript 3, so we have 3 of those. Na, we only have 1. Oxygen, we only have 1. And hydrogen, we only have 1. On the other side of the equation, we have Al, well there's 1, there's no more here. Cl, here we have 1. Na, we have 1 Na here, and 1 Na here, that makes 2. Oxygen, that says liquid, not 1, that's not a subscript, that's in parentheses to denote the type of matter. So we only have 1 oxygen here, but yet we have 2 more over here. That's 2 plus 1 is 3. And hydrogen, we have 2. So is this equation balanced? Well, are the number of atoms equal on either side of the equation for those elements? Nope, not balanced. So this does not represent a chemical reaction. A true chemical reaction does not represent that. And only balanced equations represent reactions and also confirm the law of conservation of mass. Meaning what goes into a chemical reaction must come out. Every element present has to be on both sides and equal numbers of atoms of each. All right.